Hello, everyone.
Hi, good morning.
Hello, Drew.
Hello.
Okay, let's wait a few seconds or maybe a minute or two, and then we can get started. Um,
Hello.
Hello, Florian. Let me just prepare a few things here. Hello, David. Okay, I think we can get started. Okay. So, welcome everyone. Today I invited you for the Harbor Satellite Kickoff. And in the today's sessions of roughly about 30 minutes, we would like to, or I would like to present the Harbor satellite concept and also introduce everyone to each other because we have different participants in here today from various backgrounds and various intentions, right? And how they want to contribute and help here project. So we have a few LFX, Linux Foundation mentees here, or people who would like to become mentees. We have some customers or potential users of this concept here, or companies from the CNCF who are using something similar or working on something similar. So have their opinions. We have also kind of a requirements from other organizations that I will bring with me today. And we have also people from the infrastructure or the library side that we would like to use, and I would like to explain more of that in detail. All right, so I'll bring up the agenda quickly. So first, high-level overview, then meeting other participants, roughly timeline, what we want to achieve and when, who is going to be responsible for what or what roles everyone's playing here, and where do we communicate and how we communicate and where and how do we meet. And then we have some time for question and answers, right? So let me get quickly started with Harbor Satellite. I'll try to make it as short as possible. I see that this session is recorded, so we can share this one. David is asking if there is a doc for this meeting of notes. We actually had a note bot here, that was making notes, but we don't have one at the moment. So I'm making just a note classical on pen and paper. So I'll send out the note afterwards. All right, so let me just quickly share my screen. And So you should be able to see the PowerPoint presentation, right? Okay, so Harbor Satellite. Let me just quickly look at Harbor Satellite, what we're trying to do. So we want to like to bring the container registries closer to the workloads, so closer to the edge locations. And the main reason is that we are, well, but customers of people are running container workloads in locations that are outside of the cloud, and those locations need a container registry to be able to fetch images from there, because there are multiple workloads, multiple nodes running containers, and it's not feasible to always go and reach out to the cloud to download images, right? And this is specifically the use case for edge IoT devices, so environments where there is no permanent connection, or environments where there is there's only occasional connection to the internet. So we have would like to have a high available container registry on the edge so that the workloads can fetch those images and work on that, right? So why does it matter, right? So why does it matter is because we see that containers are becoming now omnipresent. So there are even little small devices are running containers like I/O panels, for example, or like things where you wouldn't expect a container to be present, right? And all those workloads need to have a container registry somewhere. It might be in many occasions it's in the cloud, but in other occasions, like on a factory floor, this is not possible. So there must be somewhere that is nearby. And this means that if you are running like hundreds and thousands of registries, you need to have a way how you can manage that. And the best possible way is that you have a central registry like Harbor, and then from there you distribute the images to the edge locations, and then from the edge locations, nodes can use these images and run and operate, right? So we've been discussing and designing this concept for quite some time, and we did various iterations over it. So we started first with the concept of having some sort of a tunnel, where we're establishing a tunnel from the edge location to the Harbor registry, and then over the tunnel we can push the images into that registry, right? So we tried different scenarios, and one scenario that I like personally, that I discovered basically recently, and I like it very much, is a project which is called Spiegel. And if you don't speak Swedish, which is likely the case, Spiegel means mirror in Swedish. And this is basically what Spiegel does. It is using a libp2p library, so it's a peer-to-peer protocol that is established across multiple nodes. So we see in the diagram here that we have, in this case, it's a Kubernetes based. So on the Kubernetes, we have multiple nodes, and those nodes are interconnected with each other, so that image pools are not going straight to the internet or to the outside registry, but are happening across other nodes in this cluster. And then the nodes are serving those layers to the requesting node, and this interconnection is happening with libp2p. And this is also where we have requested support from the people of libp2p to see if they can help us integrate or work on that regarding Harbor, right? And I see a few possibilities here when we're talking about Harbor and satellite. So let me just go back to the drawing. I'm now here. So I see two possibilities here. First possibility is, of course, on this channel side can be a possibility to use libp2p on this connection, but also on this connection. Let me just draw this thing a bit differently. So imagine we have, let's say, registry where we're using Spiegel together with Harbor Satellite. So we have here multiple Kubernetes nodes, right? Those Kubernetes nodes are, let me just use a different color here. And those Kubernetes nodes are interconnected with each other using this peer-to-peer protocol, right? And so what happens now is that we design something that would put our satellite, let's call let's call this the whole satellite concept here, right? This one is our let me ungroup this one. Right, so let's call this one our satellite here, and this would then put our satellite here into this group, right? This is my kind of a high level assumption, and so we have a kind of a peer-to-peer network across this this cluster, and here this the satellite can be in, let's say it can be in the same network, or it can be in a nearby network in the same node, or in an outside node. So those can be in the same hardware or a different hardware. So they can be kind of a separated, but in the same network, or somehow capable of a connection between those, right? So we have those approaches, or those, how to say, possibilities here, right? So this is what the reason why what Spiegel is doing is somehow very interesting for Harbor Satellite as well, because the main advantages that we can overcome with using something similar to Spiegel is that the requirements of drivers and CSI drivers and state in Kubernetes becomes less of a problem to deal with, right? Because like if you want to have a state in a Kubernetes cluster, you need to install kind of the drivers and drivers tools that can kind of manage state across multiple nodes. And with this approach, we're using the existing state store of the nodes where the image layers are stored. We're using them as a storage for our own registry, right, or our own data. And this means that the whole thing becomes easy to manage and to set up and to maintain, right? And so
in that first diagram, in the Spiegel diagram, has that registry down in the lower right hand corner.
Well, yes.
Is that be your Harbor Satellite in your drawing?
Yeah, you could say that here. I mean, here in the drawing of here, the registry mentioned here is the outside registry, right? So this is here designed as a cloud registry, but in our case, this would be this would be likely the satellite as kind of a proxy, right? As a proxy, and then this would be connecting to another registry, which is really outside, right? So this would be kind of more like this, right? So this is the correct assumption here, right? Because the reason why using only Spiegel instead of, let's say, building something like satellite, the reason for that, in my opinion, is to have the possibility that you can control and prepend more granular what should be on the edge, right? So with Spiegel, you have the downside that it's just acting as a proxy, right? So if you need to do something, or you need to pull images and the image is not there, it is always fetching from the outside, right? And if we would have satellite, we can preload the images on the device or on the edge location, and then once the image is needed, it can be loaded, right? So there is no connection needed to the outside then. And this can be partly done exactly like this one, like so that we don't treat this external registry as external, but as an internal one. But here we would have the problem that we would need to take care of the storage, right? So if it's outside of Kubernetes, it's okay. But if it's somehow inside the Kubernetes cluster, things become more complicated, and we might do it a bit differently here, right? And the thing is that, so what Spiegel does is it implements the registry API so that this request here, right, can happen from node to node, right? So this is like the protocol here. So this is basically the high level concept of what we're trying to achieve. And the goal is that we're trying to use an existing registry, so we should not re-implement things. So we're using probably Docker distribution. This is currently in scope. What should be used? So Docker distribution will be used, and then on top of Docker distribution, there's going to be some component that we are planning to develop, which will be the satellite core, and the satellite core is then responsible for fetching data from Harbor, and this data that it will be fetched, it will basically will do self-registration. It will be also responsible for fetching a list of images that needs to be present on the registry, right? So Harbor will use replication methods to tell what images should be present on the edge, right? And there's going to be a list created with existing capabilities of Harbor. There's going to be a list created what images should be present at which location, and Satellite Core will download this list, and it's going to be somehow messaging protocol or something like this, right? So it might be going this way. So this Satellite Core will have a list of images that it needs to push to the registry, and then the registry will contain those images, and Satellite Core will just basically shift the images from Harbor to the local registry, and then local registry will be interconnected with the other nodes. So it might be even happen like this, right? So that that the Spiegel nodes will just fetch the data from the registry, or it will be part of this peer-to-peer network. Okay, good. So I think, are there any questions so that we can make a clarification before we continue?
Saba's got
Maybe-
something. I was just going to ask, what's the scope of the work for this project?
The scope of work, you mean what you want to complete? Or
Well, yeah, just what's the scope of work for this mentorship, menteeship thing?
well,
Yeah.
the scope of work, I mean, it depends, right? So I mean, we want to try to complete as much as possible, but of course, it's not feasible to achieve everything in 3 months. So we have like 3 months time for the LFX program. So there's going to be a next LFX program and the next LFX program. So we hope by the end of the year, or we will have something that is usable in the space. And for the current scope, where Walt is working on or planning to work, we need to define the scope still. So I'm not sure what we need to carve out as the first part. I think this needs to be discussed in the next step. Saba, you had also a question? We can hear you if you're telling something. Saba, are you saying something? Because we cannot hear you. You just okay. Issue the mic. Good. So
Fixed
yes,
it.
we can.
It defaulted to another mic. Yeah, so I know we haven't done introductions yet, but I come from the infra engineer side of things. So I've seen this very specific problem in production for a shipping company in the past. So my question is, so I really like the distributed nature with Spiegel that you've shown. And this might be my very, very siloed experience, but in the use cases that I've seen those Kubernetes clusters had a single node. So how does that, it might be a very, very specific thing, but the vessels that I've seen, they had one master and one worker. So this entire idea depends on a multi-worker node. I know you shouldn't be running Kubernetes if you only have one worker node, but the industry's reality is, or the reality that I've seen was this.
And I mean, it will also work with one node, right? So I think it's not limited to being only, working on multiple nodes. So it can also run on one node. So if you want to run everything on one node, it can definitely run on one node. So the goal here is to have run the satellite inside Kubernetes cluster, but also outside Kubernetes cluster, so that we will have or fulfill the requirement of bootstrapping a Kubernetes cluster on the edge, right? So this is of also a use case that we would like to accomplish, right? Being able to bootstrap a Kubernetes cluster that is on the edge, right? So that means that the Kubernetes cluster can bootstrap itself, right? So you can make installation. And of course, the reliability and things not going to be as powerful as with the multi-node cluster, but it definitely should be able to work just with one node in a cluster.
I've only asked because of the Spiegel architecture, which kind of depends on having more than one node. But I understand what you said. The other question that I have is in this drawing, I'm really interested in how the connectivity between the Harbor instance on both on the edge, so the satellite core and the nodes would be established. And you've talked about tunneling between the edge instance and the remote instance. So if you could say a few sentences about those, that would be much appreciated.
So you mean about this connection here, right?
Yes, but also the one that you have drawn between that triple node and the actual
This
registry itself, because that's something that I don't see is how do you want to do connectivity between the node and that instance, that local Harbor instance.
Okay. So here, let's talk first about this part here, right? As I said, the first approach here was to have a kind of a tunneling software or something, kind of WireGuard protocol, things like this. But we came to the conclusion that this doesn't, scales in the thousands, and the complexity of managing and maintaining this connectivity might be a bit complicated. So it would be much easier for the satellite core to either pull for a chain set, or using some sort of notifications to be able to, get this chain set fetched. And the connection here will be from, not be going to be like this. I think it's more like this, right? Because the satellite core is the one who is initiating the pull, and then it's pushing the images to the registry. So it's more like satellite core is fetching the images from Harbor, and then it will, push those images into its local registry. Whether it's in a single binary or it's two binaries, it's to be defined. But it's logically I put it here, the connection, but physically it would be probably much here. So it's basically a normal connection, right? It's an HTTP connection from satellite core to Harbor. So there is no magic. The only requirement that we have is that it's an outbound connection. So there's no possibility to make an inbound connection because I think this is going to be much more harder to implement for the edge locations. And here on this side, I mean, the expectation is that the edge the edge registry or satellite is somehow present in the same network, right? So if we talk about look at those two networks, on the left side the cloud, and there's a firewall and separation in between, and we can expect that somehow those those instances are running really closely together on the same network. And here the connection would be then just the normal connection from client server, maybe over lib P2P. It depends a bit on that. Does this answer your question, Saba?
Yeah, mostly. I just really want to see that connectivity between the nodes and the edge instance established, but that might be my shortcoming, so it's no fault of yours.
Mm-hmm. Yeah, I mean, do you have something more in particular? Because for me, this is a normal kind of an intranet connection. So my assumption here is that those workloads are closely related to each other, or that those workloads are close to each other here.
No, what
The
I've
same
seen
network.
is what I've seen implemented was that Harbor ran in the cluster itself, not in this architecture. That's why I said it's probably my shortcoming.
Yeah, so this is generally a problem, right? So if you run Harbor on the same cluster that serves the images, it's generally a problem. So you either run it on the same cluster and then take the risks that if something is broken, you cannot bootstrap yourself, or you run the Harbor cluster maybe on the same node but outside of the Kubernetes, right? So maybe just run it on the master node, but not inside the pod, right? As a pod, but just as a container, things like this. So that if the cluster goes down, the node is still able to order the application. They're still working and able to serve the images. Okay, so let's make then the next step and do a quick introduction round. Probably I should have done it before. Sorry for this for not making structure it correct in a better way. But let's make a quick introduction round. Xaba, would you like to start and kind of say hi?
Yeah, it makes sense since I already talked. So hi everyone, my name is Csaba. I'm here through the LFX mentorship angle. So I'm just going to keep it short. I'm an infra engineer. I've been provisioning clusters on the edge for certain customers when I work for Microsoft. And the reason why I'm here is I'm currently on a sabbatical and just want to contribute to open source and want to solve this very specific problem because it seems really cool.
Thank you, Xaba. Drew, would you like to quickly introduce yourself?
Sure. So hi everyone. I'm currently a student at the University of Michigan. I'm about to graduate in May, and I'm interested in this project because I want to contribute to open source project and have my initial open source experience with Harbor. And I used to be a DevOps intern in another company, and I'm really interested in contributing to Kubernetes and all this stuff, though I'm not totally I'm not as well as experienced as others in this project, but I have really I have really strong interest in developing this project. From my point of view, I think it's probably like very like a CDN concept in web development, and I seen the host introduction, so I'm really interested and have a strong preference for this project. Thank you.
All right. Thank you, Drew. Roald?
Yes, hello. So my name is Roald Brunel. I'm a student in Switzerland at the HESSO, and I am in my doing my bachelor's thesis this semester. And so this project will be part of that. And as Vadim said, we still have to precise the scope of this project, but I will be working on the satellite core harbor satellite part of this project. And I'm also very interested in this open source concept, and I think it's great to be able to contribute to open source projects like this. So, yeah.
All right, thank you. David, would you like to say hi again?
Yes, I'm Dave. I am actually a former Linux Foundation security maven at Hyperledger and community architect. And, I used to run the mentorship program for Hyperledger for many years. And now I am over working as the community architect on the libp2p project. I was formerly an employee at Protocol Labs, but now I am officially the community architect. And I am your greatest resource in connecting you to libp2p developers, and anything you might need in terms of learning materials or just a quick like, hey, how do I do this? We have a ton of learning resources online that I'd be happy to share and help get you connected to the right people to get your your questions answered. So yeah.
Can you give a quick 2-3 sentences about libp2p and why it might be relevant for Harbor Satellite?
Oh, yeah. So libp2p, excuse me one second. Okay. libp2p is like it says here, it's a modular open source network stack that was designed initially as part of the Interplanetary File System, or IPFS, and has moved out into its own project like 3.5 years ago. It is a network stack that is designed to be an easy place for protocol design and testing and research. It has a bunch of the normal peer-to-peer things built into it. So coming out of the box, you get Kademlia, you get peer discovery, you get peer routing, you get hole punching through NATs, you get support for multiple transports and protocol introspection and all those things. It is actually a set of specifications more than anything, but there are 11 implementations of libp2p in various degrees of completion. As you can see here, the main ones that are actively developed today, there's 6. There is a Go libp2p implementation, there's a Rust libp2p implementation, there's a JavaScript libp2p implementation, there's Python, there's C++, there is Zig, Nim, there's lots of them, Swift. You can see them across the top there. It is relevant in this case because there are global scale peer-to-peer networks that self-configure and are resilient to network weather, essentially. I mean, the IPFS network runs all the way out to the edges. There are IPFS nodes deployed on satellites in orbit at this point and on battleships in the Navy, things like that. And libp2p is what keeps them all connected. So this use case has already been done in other contexts, but not for necessarily container distribution and coordination, but data set distribution and coordination. So this is just a narrow special case of something that's already been done several times over. And we have a vibrant community, lots of developers. We hang out on lots of different chat rooms, and we have forums and everything like that. So it's very much an active open source project where you'll get lots of help, lots of support. We do hackathons often. We do libp2p days often. So whoever works on this, I would love to invite to come and speak at libp2p day in Brussels or in Bangkok this year. So it'd be really neat. I'm excited about this. Oh yeah, so not only, the last thing I want to point out, not only does libp2p support like global scale peer-to-peer networks, but it also has LAN auto discovery and stuff. So if you're inside of a firewall, like Kubernetes clusters are likely to be, it does auto discovery of peers using a number of different techniques. And there is even an application that uses Bluetooth low energy to do auto discovery of Bluetooth devices, in a personal area network as well. So It's just a toolbox of lots of very useful networking techniques that allow peers to discover and communicate, synchronize, coordinate, all that.
All right.
Yep.
Thank you very much, David.
You're welcome.
Florian, you want to say hi?
Yes, hello. I'm working for the SNCF, is a French railway company, and we are running Arbor on cloud. We have two infrastructure, and we have also some Arbor deploy on edge. So we are interested about it. And I'm also working with Jan, which is here in the meeting.
Hello, Jan.
Hi everyone. Like Florian said, yeah, I work also at CNCF, which is a customer, and I mainly work as a platform engineer, and I've deployed a few Kubernetes clusters at the edge on railway transportation. So, and I try to find a way to proxify or at least manage well my Docker images at the edge. So that's a case I'm really on. So I'm pretty excited to see what's Hubble satellite is going to bring to that problem.
All right. Thank you very much, Jan. Yeah. So you see that we have from different areas, from different expertise levels here, from the one from the user side, from the foundation side, like the lib P2P, and also from the engineering side, like Saba said, or is from, right? So from the use case side, from on the cloud. So the high level timelines, right? The next topic is what do we want to achieve in what time, right? And I think like the whole thing is, driven from the student perspective, right? So we need to respect that, and we cannot set expectations beyond what a graduate student is capable of implementing. So we need to have a flexible timeline and flexible deliverables on what can be delivered. And this is something that we need to, in particular, to discuss with Roland, not what he's capable, but also what can be part of his bachelor thesis. But my goal is here to have a solution running, right? So having a POC working after those 3 months here, that we have a solution that is kind of proved to work. And then we can iterate on that in the next LFX program and in the next month, and build upon that to have it probably general available at the end of the year. So we will have 2 LFX programs, and there are going to be also other, people contributing to that, including myself and also someone from our team that will contribute to the project. And we'll also have, we probably need also to make some changes on the harbor side. So I would say I purposely left out the harbor side a bit because it's a bit difficult to change and extend. And I identified a way how we can extend harbor with no to little friction, so that we can use the existing capabilities of harbor with let's say a tool which is called ground control that will be sit next to harbor, so that we can extend harbor very easily, and then use the extension of harbor to fulfill our requirements on the satellite core, right? So I think that the focus will be more on the satellite core here, because a lot of those things can be, let's say, in the proof of concept phase can be, I would say, mocked, but they can be performed without changes on the harbor side, right? To make this whole case fly. Okay. So this is then roughly the high-level timeline that we would like to achieve, having a proof of concept here on the right side, proving that this thing is working at the end of the ethics program. And as we already had the introduction, I would like to also kind of present the roles of the people, and I think it was also already partly clear in the introduction, right? So I can say about my role. My role is, coordinating the project, making sure that everyone is on board. I also contribute to the architectural design. I'll try to code as much as I can, but I cannot promise too much here, as my time is limited. But I can work on this architectural design. I can connect the right people with each other so that problems and question can be solved. And as you already saw in the introduction, like David is on the libp2p side, so his role and responsibility would be here to kind of help and answer questions that are libp2p related, or also answer questions towards libp2p to say, is this possible with libp2p, or how can this be achieved, whatever this is, but how can this be achieved with libp2p? Is it feasible or not, or does it make sense or not? So I think David is here as a kind of as a consulting person, or the father of not father, but yeah, the godfather of libp2p, and answering maybe questions towards us if this makes sense using libp2p for that, right? Is this a bit about right, David?
Oh yeah, this is more than feasible. Like I said earlier, this has already been done in other contexts for doing very, very similar things, pushing data sets out to the edge or on devices or in environments that have limited or intermittent connectivity. Like I said, IPFS has been deployed in satellites. There's also military applications for ships at sea and things like that. So this is 100% right in the wheelhouse of libp2p. This is exactly what it's used for.
All right, thank you. And then we have Florian and Jan from CNCF, who would be, I think, able, right, to provide some requirements and also, provide ideas and how they currently use Harbor at Edge, or how it would, fit into their use case. So this is how I would see the role and responsibility of Jan and Florian.
Yeah, I agree.
Okay, right, and then we have the LFX mentees, in particular Drew, who is currently here, Xaba, Fikar probably, and also Roald, who will do the implementation of this functionality. And here we need to, see how we can, schedule the workloads, or find a way who will be working on what. And this is something that we need to discuss in more details later on. But for now, this is like the part you will be probably working on, is the satellite core part here, right? We don't have currently today here, but I talked already with the author of Spiegel, right? So it's Philip, and he also agreed to help us and be on board when we need to integrate or extend or modify, or to do whatever we need to do with Spiegel, so that we can implement our use case. So he volunteered and offered his time to be able to consult on the Spiegel use cases, so we can also use him as someone to ask questions toward Spiegel in similar way we can use David for asking regarding the P2P. Right. For the next topic, the communication channels, I'm suggesting to use the Slack channel, the CNCF Slack channel for our communication. And there is currently LFX program channel for the that we can use, but I'll probably will create a new one, which will be specifically regarding Harbor Satellite, because this is something that, you know, if it a lot of discussions, we won't bother the others here, and I think it will also be possible for others to join from the community to follow the discussions and also maybe provide an opportunity to communicate. So I would suggest that we use the Slack channel in the CNCF that will be created. Will be called Harbor Satellite, and we use the Slack channel for our communication and also planning and things from now on. All right. Now we have some time for question and answers. So,
do you have a link to the Harbor Satellite Slack channel, or if you haven't created it, are you going to send that out for us? Because I'd like
yes,
to.
I'll send it out afterwards because I need to create it and I cannot do it myself. So I need to make a request to make the created channel, and it will take some time until it gets created.
Then my other question is, what is the likely language implementation of libp2p to be used? Is it
Golang?
Golang. Okay, I can drag in some mentors from the Go libp2p project to hang out in the Slack channel.
All right, that would be great. Yeah, I'll send it.
I'll find some volunteers who will help answer questions.
Okay, thank you very much, David.
Yeah.
Okay. So, are there any other questions regarding timeline, roles, things like this, or the next steps?
I have a question. So regarding the recording of this meeting, will it be posted on Slack or on some other platforms?
Yeah, the recording will be published. I think it will be published as a YouTube video. It will not be public for on the internet, but it will be, you know, visible if you have a link. And I'll paste the recording into the email that I've sent to you, and I also use the same email to you know, send you the channel, the communication channel, and also the link to the video, to the recording.
Okay, that's helpful. Thank you so much.
I have a more pragmatic question, if you don't mind. So
Yes,
how are we going to collaborate on this in terms of code?
So practical, yeah. There will be a project. So I would suggest to create a project in the beginning a bit outside of the Harbor project, because the reason to do it outside of the Harbor project is easier collaboration, right? Because the Harbor project is more restricted in terms of how people can collaborate, and I would create a project inside you know, inside our org, and there we could collaborate, and I will, you know, grant everyone the right permission so that we can move fast without being blocked from, you know, from permissions and approval process and things like this, right? And then when things get more mature, we can move it over to the Harbor project, and then we can, you know, all those typical open source the processes will apply then.
Okay, so separate repo, that's straightforward enough. How do you want to manage tasks themselves?
Also on GitHub. So task I would like to do managing on GitHub. I'll create a GitHub project probably, or doing the task on GitHub so we can manage those things in close to the repository. And I'm thinking of just having one repository for everything, right? And then we can use that one.
If I may have a suggestion at this point, since I might be wrong on this one, but there's only one official mentee, and the rest of us are basically best effort with extra level of commitment. So we promise to deliver to a certain extent. But for me personally, it would be really nice if we had a classic Kanban board and just pick the top off of it, so that I don't have to check with anyone about what the priority is or whatever. I just look at the board, pick the top, start working on it, finish it in a reasonable amount of time, and just go with trunk-based development from there. So I don't know if you want to do releases or feature branching or anything like that. I personally wouldn't. Just try to keep it as simple as possible with most synchronous work as possible.
Yeah, trunk-based is a good approach for me. I like it as well, and also it's fine for me to do it Kanban style. We can implement it in Kanban, as in a Kanban board, and put on the tasks, and we can also we'll have a regular weekly meeting where we will have in the next one we will do some planning what we want to achieve, and then we will also kind of I wouldn't say assign task, but plan on the work that needs to be done and put this on the board, and then we can move from there. And yeah. Okay.
But
All
is it
right.
okay for is it okay for the others who will be actively contributing? Because me and Vadim can decide on our own, but it's probably not the best for you. So if you have anything that you would like to do differently, then I think this is the time before we start putting together the board.
This sounds good to me, so I'm all okay with this.
I think we need to, but this is more a task on my side, right? Because I'm also kind of as a mentor, I'm also responsible for Roald, because in two ways, like as a mentor on one hand, but also as someone who is also, taking care that he's doing his bachelor thesis. So because he wants to do his bachelor thesis about satellite, so we need to work out what should be part of this thesis, right? So that he can kind of work on that, and I think we should find a way in the community how we can address that, so that, let's say, the tasks assigned to rollout will not get snagged, but I think we'll find a way how we can find a solution here, right? Okay, yeah. So going forward, I will set up a regular meeting where we'll be, discuss progress and also do some planning. And I think there are going to be also more of an ad hoc meetings where we do some, architectural brainstorming. And this is also something where I will be inviting everyone to join, because there is no kind of a separation, right? So I will join people for different types of meetings, everyone. And if you're able to join, then join, and then we can then do some architectural planning and also some brainstorming further down on the implementation, and then also use this time then in a kind of in the planning session to plan also the tasks that need to be done in a particular then repository then.
Sorry, but I have another practical question. Do we have an idea on how do we want to emulate the edge in the development cycle?
How we doing? Okay. So are you thinking about something practical in a way that real hardware, or?
I mean, real hardware would be the best that we can access remotely, preferably. But I'm open to anything. I'm just thinking in, again, pragmatic terms of how am I going to contribute, and how will the cycle look like?
Mm-hmm. I mean, we could definitely provide hardware, right? So we have something in the office that can be used, but we can also use some cloud provider hardware, right? So we can use EC2 instances and pretend it's an edge device, right? So I think it's also possible. Yeah.
Cloud is okay, but I think the real meat on the bone here is to simulate a spotty network. And if we could do that in an automated fashion, I know Chaos Studio in Azure, and there's probably other ones in other cloud providers as well, you can kind of model these kind of disaster scenarios, and we could just model using like losing connectivity with those. But as I said, I'm open to anything, just brainstorming here.
Mm-hmm. Yeah. I mean, if we have this in the office, we can, yeah, it's a reliable connection there as well, right? So it's not a big difference than to have an EC2 instance. Yeah, we need to find a way how we can find an infrastructure, test infrastructure or test bed, right? So maybe we can find something here.
libp2p has a platform called Testground that built specifically to test peer-to-peer networks up to many tens of thousands, and it has an internet weather kind of capability where it will not only just create intermittent connections, but it'll create slow connections, things like that. There's a lot of failure scenarios that are not actual failures, right? Like, yeah, we're connected and bytes are going through, but at like 100 bytes per second, for instance. So it's not linked to on our webpage. It's in our GitHub repos. It's called Testground. It's a scriptable, it's kind of a heavyweight tool though. We don't actually use it for interop testing at the moment. But yeah, Testground. And then there's also Shadow, which I have used when I worked on the Tor project. We used that to test the Tor network.
Mm-hmm.
That's not it. I don't think it's that one right there. The Testground, third one down.
Okay. It's the same. The same.
Oh yeah, I
background
guess
logo,
it is. I guess it is.
Yeah.
Yeah. So this
Okay.
was developed to do like large scale network simulation and testing for libp2p. So we could optimize like the distributed hash table and things like that. Test IPFS.
Okay. Well, that's something to look at then.
Yeah.
I'll take a note. That's
And
cool.
the person who helped design this is actually one of the primaries on the libp2p Foundation. The guy named Raul Kripalani. He's a really smart guy. We can talk to him. Yeah, Raul. Yep. I was just talking to him over the weekend. So he's still very active. And so if this is a route we want to go, I'm sure we could set up a meeting with Raul and have him, or at least have him connect us with people who are active on the project.
Mm-hmm, mm-hmm.
Yep.
Okay. Yeah, any other questions? Okay, then. Thank you very much for attending, and I'll send out the notes and also the recording and also the channel that we have, and also we'll create a new meeting where we can discuss and finalize the architecture and also start with the task planning. All right, everyone. Thank you very much for your contribution and being present today. And I'll see you on Slack. Thank you very much, everyone. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.
Bye.
Thank you. Goodbye.
Thank you. Goodbye.